If I underline something, you underline it. If I circle it, you circle it. Word median. Does that sort of look like the word midpoint? Does it have similar letters? Does it have an M and a D in it? You should be thinking midpoint when you see the term median. If it shows up in a problem, we're actually talking about a segment. Let's put this in red. And let's make that point D. If point D is a midpoint, what am I allowed to throw into the drawing? Slash marks. So that's really what you should be thinking when the term median shows up in a problem. You're allowed to put in something showing that something is being cut in half. The median is actually that segment. Median. But we have 3 sides and 3 vertices in a triangle. So I could put a median from A to this side. I could put a median from here over to here. All of those are considered medians. They go from a vertex point to a midpoint. Where are all of these? Inside or outside? All medians are interior. Next week we'll talk about what happens when we have all 3 at once. We'll take a look at some constructions. What's another word for altitude? Height? If you're measuring somebody's height, do you measure it at an angle? No, you measure it straight up and down. What do I mean by straight up and down? What angle am I forming with the ground? 90. So it all depends on what you call the ground. We don't use the term ground in geometry. What term would be a better term to use? So let's consider AC to be the base. If that's the ground or the base, and I want to do the height or the altitude, I would come from B straight down at a right angle. My altitude would be that segment. But if I'm looking at a specific type of area problem later on in chapters 11 and 12, and maybe I don't have this distance, but maybe I've got this distance. Maybe I want to consider that side to be the ground floor or the base. In that case, my altitude would be from A to BC. Three sides, 3 possible bases. I could put my base over here. Where would my altitude be then? Where would I start? Point C to this base. Just make sure that it's a right angle. So depending on what information is handed to you in a surface area problem, you might want to look at this is the bottom, this is the bottom, or this is the bottom, depending on the circumstances. These were acute triangles, so all of the altitudes were inside. Next week, we will take a look at what happens when we put all 3 together, and we'll do some constructions with that. These are all right triangles, so let's put in some right angles. A right angle is exactly what we need when we're talking about an altitude. So we've got built-in altitudes. If we consider this to be the base, then this side would be the altitude. if I want this to be the base, what would be the altitude? What's the name of that side? DF. So I don't have to draw anything in because it's already...
Good morning, Bruins, and happy Friday. Please excuse this interruption. At this time, please release all students who have SOL passes to their respective labs. Thank you.
So we've got some built-in altitudes if we need them. If I make the hypotenuse the base, then I've got a slightly different situation where that would be my altitude. So for right triangles, sometimes the altitudes are parts of the triangle. What do we call these two sides? This side and this side. Not less. Legs. Sometimes the legs can be used as our altitudes. If you look at that, what is that? Leaning Tower of Pisa. If you're going to measure the height of the Leaning Tower of Pisa, are you going to measure along here? What are you going to do? Create a line. I heard something. Where do you create a line? Where? At the bottom? And then go up to where? To the top. Or how about if we go up to the top and we drop a straight line down? What do we mean by straight? 90 degrees. So I'm not going to measure the length of the tower if I want the height. That's what you're sort of looking at here with an obtuse triangle. I want this to be the base. And remember, you want the altitude to be the height. Well, what's the height of this triangle? You'd have to drop an altitude down to here, which means that you extend what you consider to be the base in order to see the right angle. The base is still only this distance. Just because we extended it doesn't mean we included it in any calculation work. It's just to see where my right angle is. If this is the base, then my altitude is normal inside. If this is the base, if it helps you turn your paper until this is actually looking like the bottom of the triangle. Tilt it a little bit, and then you can see that you'll have to extend your base a little bit in order to drop down a height. We've got altitudes that are on the outside of the figure, and then we've got one that's inside the figure. Once again, what you want to be the base depends on what information is handed to you in whatever problem you're doing. If you've got this information, this distance, then you're going to want to make that the base. If you've got this information inside the figure, you might want to make this the base. This will make a little more sense when we get to chapters 11 and 12. Page 2. Did we do a compass construction called the fish? I'm not going to actually use the compass, but that's what they're asking for up here. What did I have to do or do to complete the construction once I got those intersecting points? Connect them? what if my drawing didn't look too good? What would give me full credit? Actually show this and this. Show the perpendicularity, and then show the bisecting with some stuff. Eventually, when we get about 5 of those constructions done, we'll have a quiz on it. It'll be totally separate from any other test or quiz. You don't have to worry about that for Monday. For this, let's cross this out. And we're just going to make this into an isosceles triangle. And then I'll place a new segment in here called LM. Why am I allowed to do this? Reflexive property. It turns out that if I've got a median and an altitude combined into one, that really means I've got a perpendicular bisector. If I've got a perpendicular bisector, that means that I'm dividing up this triangle into 2 equal parts. This triangle and this triangle are exactly the same for a variety of reasons. SAS, SSS. So if something is isosceles, then the median, altitude, and perpendicular bisector are the same segment. That is the median. That is the perpendicular bisector. That is the altitude. That's also true for equilateral triangles too. Go ahead, you do 1 through 9. But do this first. It doesn't actually say given, but this is given information. This is given information. So put it into your drawings before you start.